Okay, to start this problem, I would like to multiply this to the other side of the inequality, but I don't know if it's positive or negative, so I'm going to set up two cases. Case 1 is going to be where 3x plus 2 is positive, and case 2 will be where 3x plus 2 is negative. So this would mean x is greater than negative 2/3 if I subtract the 2 to the other side and then divide out the 3. In this case would be x less than negative 2/3 using the same math. So I'm just establishing two cases that I'm going to do. And like I said, that's just because I don't know when I go to multiply it if it's positive or negative. So that will affect the problem. Now I'm just going to rewrite my problem. Two times. Okay, first on the left, my case 1, the math's real straightforward. I'll just multiply my 3x plus 2 to the other side. Multiply it out. I'll subtract 6x on each side and get x is less than 4. The math in the other one will look similar, only in the first step when I multiply. Since I set this problem up on purpose to make this negative up here, when I multiply it to the other side, it's going to reverse the inequality. So instead of less than, I'm going to have greater than 2, because when I multiplied this, it's negative. So I'll do the same math, but my inequality is reversed. Subtract the 6x, x is greater than 4. Okay, so now to evaluate what my answer is, in the first case, I'm looking at x is less than 4, and x is also greater than negative 2/3. And that makes sense. I have numbers that are both, so I could say x is less than 4 and greater than negative 2/3. Now in this other case, x has to be greater than 4 and less than negative 2/3. No number could meet both of those. A number cannot be more than 4 and at the same time be less than negative 2/3, so I don't have any solutions in that case. So I'm hoping when I check my book, this will be the answer to number 37. Yep. Okay, in problem 29, I'm going to need to set up two cases once again. One case is going to be where 3x is positive, and the other case will be where 3x is negative. Because when I go to multiply this to the other side, that makes a difference in my math, whether it's positive or negative. So in this case, if I divide the 3 to each side, I have x greater than 0 or x less than 0. Those are my two cases. So here's case 1, here's case 2. Now I'm just going to copy the problem down twice. So I have x plus 3 over 3x is greater than 2, and I have x plus 3 over 3x is greater than 2. So I just copied it down. Now when I do the math, on the left-hand side, I'm going to multiply the 3x to the other side, subtract an x, divide out the 5. Now I like to have my x on the left, so the inequality still points at the x. Now, in every one of these problems, the math is going to come out the same, but the other answer is going to have the inequality switched. So if you want, you can go through the steps, but you wouldn't really have to. If you don't want to. And then to evaluate my answer, I have to consider, okay, I need numbers less than 3/5 and greater than 0. There are some numbers like that, so I'm going to have an answer from that one. X is less than 3/5 and greater than 0. And then when I look over here, x greater than 3/5 and less than 0, that doesn't have any answers. So with any luck, this should be the answer to number 29. Okay, number 31. Okay, in this problem, the thing that I'm going to be multiplying to the other side is the 3x. So that's the thing that I'd use to set up my two cases. So I'm going to say case 1. That's going to be the case where 3x is greater than 0. Case 2. That's going to be the case where 3x is less than 0. Because I'm not really sure, with it being an inequality, I don't really know if it's going to be negative or positive. So if I divide out the 3, x is greater than 0, or x is less than 0. That's the cases. Now I'm just going to write down the problem 2 times. X minus 5 over 3x is less than negative 3. Okay, so now on the left, I'm going to multiply my 3x to the other side. I guess I'll subtract an x on each side. Now divide out my 10. And I like my x on the left. Now in the other case, I could do all the same math, only it's going to switch the inequality. And I'll have x is less than 1/2. Alright, then I'll go to look for my answers. X greater than 1/2 and greater than 0. Oh, I see. You have trouble isolating the answer here, maybe. I need numbers that meet both of those conditions. So in this case, it would just be this one. Because for a number to be greater than 1/2 and greater than 0, it would have to be greater than 1/2.
That's the answer?
That's one of them. I'm going to still have to look at the other case. I look for numbers less than 1/2 and less than 0. Those would be all numbers less than 0. So it looks like I have 2 answers here. X is greater than 1/2 or x is less than 0. I'm going to have to check my answer because it doesn't seem to agree with the book's answer. They have x is less than 1/2 and greater than 0. I'll double check my math.
Maybe because...
Found my mistake. When I divided by a negative right here, I should have reversed my inequality. So let's get rid of some of these marks that I put on here. Go back and fix this problem. So if you're watching this video and you saw my mistake, good for you. Because I should have noticed when I divided by negative 10, I should have 1/2, but that would have switched this. And then this problem would have the less than. Wait, this has less than. This problem would have a greater than. Okay, let's go back and check these answers again. X less than 1/2 and greater than 0. There are numbers between 1/2 and 0. So that's one answer. Then when I look at this, numbers greater than 1/2 and less than 0, that doesn't have any answers. So the one in the circle would be my only answer to this question.